everyone, my name is Ajad Imrabul Khalam. Today I am going to present a research article authored by the researchers of two renowned AI-based companies, Google AI and DeepMind. The title of the paper is Likelihood Ratios for Out-of-Distribution Detection. So let's begin with the overview. First, I am going to introduce out-of-distribution, in short OOD, and its relation with the likelihood. Then I will discuss the background with bacteria identification and exploring the deep ocean. Then I will move to the most important part where I will explain the likelihood ratio and its uses to OOD detection. Then we will see the results of the proposed method, and finally I will end this presentation with giving you some take-home messages in the conclusion. Additionally, I have included the reference on the last slide in case you are further interested. So let's begin with the introduction. Out of distribution. To understand it easily, just think of an AI-based intelligent gate system which welcomes your friendly neighbors automatically and discards the dangerous neighbors. How does it do that? So it simply takes the distribution and then decides. So for this gate system, all the friendly neighbors are in distribution and the rest are out of distribution. So to distinguish between in and out of distribution, the system uses the likelihood. Likelihood is simply the probability density function. See the diagram at the left where x is equal to 14 is highly likely to be in distribution than x is equal to 10. So the essence of this, if the system predicts as high likelihood, then it is in distribution, otherwise it is out of distribution for low likelihood. This OOD detection system has many real-world applications. One is to identify bacteria based on genomic sequences. So if a new novel bacteria like COVID-19 appears, then the system will detect it as OOD and inform to take care of it in advance. Another possible application could be exploring the deep ocean to detect new species or to find the potential mines. However, this likelihood-based OOD detection system can achieve high accuracy when you test the system. But the problem is it can show miserable performance in real world because 60 to 80% real world data are totally unknown to the system and are wrongly assigned high likelihood than just saying I don't know. We can observe this behavior in these two histograms. The left one is for the bacteria and the right one is for the two famous image datasets, fashion MNIST and MNIST. In both cases, it is clearly visible that the system wrongly assigned high likelihood to OOD instances. So therefore, we can see the authors propose to compute likelihood ratio, like two likelihood for semantics and backgrounds instead of a single likelihood for the whole image. Then they take the ratio of these two likelihood and detect the out of distribution because they found in their research that the single likelihood is actually dominated by the unimportant background, whereas the likelihood ratio cancels out the background and takes into account only the most important semantic part. This is why they got better accuracy in their results. We can see in the left histogram, now the system correctly assigned low likelihood to OOD inputs. And also it improves the performance measurement like AUROC from 0.091 to 0.996, which is nearly a perfect model. So we can say that likelihood ratio completely outperforms the likelihood. So we are almost at the end of this presentation. So overall, we have seen the likelihood can determine the OOD, but it struggles in real world by wrongly assigning high likelihood to OOD inputs. Therefore, the authors propose to compute the likelihood ratio instead of a single likelihood, which improves the accuracy on both image and genomic datasets. And finally, they hope that this solution will work as a benchmark for the concerning research community. That's all for today. Thank you.